And then afterward, we'll go to technology, of course. See how that does it? We're going to find what's called the standard deviation. So we're going to compute the standard deviation. Now, before I start, we've talked about the word sample and population in this course, right? So you're like, all right, are we finding the sample standard deviation or a population standard deviation? For our first example, we'll find a sample standard deviation. That's what we are going to compute, a sample standard deviation. It'll be the standard deviation of a sample, right? Right, not a population like something in the millions. Cool. Well, what is standard deviation? Deviation means like distance away or deviation, the difference from data points. So would you write this down? Standard deviation measures how far on average each observation is from the mean. I'll say that a few times. I know you're writing it down or copying this. How far on average each data value is from the mean. That's roughly what it's measuring. What's the standard deviation? In the end, we're going to get a value. We'll get a number. Well, what is it? It's a measurement of how far, on average, each observation is from the mean. Now, do you want? What's a simpler way to say it? Okay, it's the average deviation from the mean. Will that work? Like it's like a measurement of the average deviation from the mean. That's what it is. That's what's important to us. We want to know what are we finding when we do all this. And deviation, everyone, we're just going to do a subtraction. So, sample standard deviation, I say we start with a simple example. How about the numbers 1, 2, 3, 4, 5? All right, there's our sample. I even put some neat braces around it. That's our sample, the numbers 1, 2, 3, 4, and 5. And we're going to compute the sample standard deviation. The standard deviation of that sample. All right. So we're going to compute sample standard deviation. Okay. Well, again, I said this is the average deviation from the mean, right? This is going to be 3 steps. What do you think step 1 is? Let me repeat again. It's the average deviation from the what?
Mean. So
It's the average deviation from the what?
mean.
What do you think step 1 is?
Calculate mean.
Absolutely. Absolutely. That's it. We go step 1. Well, if it's the average deviation from the mean, our step 1 is we have to calculate the mean. If everything's based off the mean to come up with this computation, we're going to find the mean first. All right, so we're going to find the mean. Now, is it mean of a population or a sample?
Sample.
Sample. So
X bar.
I'll put the word. You remember this symbol for this?
X bar.
We're starting to get used to these symbols now. It's an X with a bar over it. You know, it's the symbol for sample mean. I'll go way over here. What's the symbol for population mean? It's a
Mu.
it's a mu. It's the Greek letter mu. That's for a population. It's already established, just so you can start getting used to these symbols. X bar, you can call it X bar. We have to add up all these numbers and then divide by, how many numbers are there?
5.
5 of them. All right, so we're going to add them all up. 1 plus 2 plus 3 plus 4 plus 5. Divide by 5. See what you get.
15 over 5. 3.
So you add them all up, you get 15. There's 5 numbers, and you get a 3. Is that when you get 3?
Uh-huh.
Well, I wanted to keep it simple for our first example. It's the way to do standard deviation the first time. All right, so that's sample mean, X bar. Step 2 is the big step. All right, I think I've got enough room here. This is the big step. This is where I'm going to do all those deviations I was talking about. A deviation is just a subtraction. But didn't I say I had to do each observation? So that's what I'm going to do. So I'm going to make a fraction bar. Make it pretty big. And I'm going to take each one of these values. There's the 1. And I'm going to subtract the mean. I think I'll color code. Every time I do the mean, I'm going to put it in yellow. So take 1 minus 3, put a parentheses, close it, put a plus. Put a 2 minus the 3. Plus. Almost done. There's a 3. I got to take 3, subtract the mean. We know what that number is. 2 more. 4 minus the 3. And lastly, 5 minus the 3. And we're going to have to add something to this in a second. Not going to be hard. We're going to add something to this. But this, we're getting a sense of what's going on here. We're summing all the deviations, right? So far. Question?
I have a question, but I figured it out.
Oh, okay, awesome. Now, Aaron, don't you think we divide by 5 here? When we do average, we divide by 5 numbers, right? When you compute the sample standard deviation, you always divide by the sample size minus 1. So you and I are going to divide by n minus 1. And I know you're sitting there going, what? What in the world is that? Why are you doing that? I don't want you to get so concerned about it, or the theory behind it. It's because this right here, it's because of the bias involved when you have these small samples that we divide by this. There's a name for this too. By the way, what's 5 minus 1?
4.
We're going to divide by 4. That's what we're going to do in this math equation. We're going to divide by a 4. It's n minus 1. So I'll put a 4 here and just make a note that this was the sample size minus 1, 5 minus 1. There's a name for this 4 though. It's called the degrees of freedom. All right. It's called the degrees of freedom. And I'll fix the numerator too. There's something else we have to fix in the numerator to make this math equation perfect. All right. What do you mean by degrees of freedom? There are 4 degrees of freedom, but there are 5 values in the sample, true? So just a quick exercise to help you understand this concept of degrees of freedom. Everyone, let's say, if you walked in here, I had 6 donuts in a box. You know, I had the sprinkles, I had the chocolate cream, I had the jelly, and I put them in here, you know, about 12:15, I put it right here. I put a sign, you know, Professor Mester here. Anybody's hungry, take one. And the first student walks in the door, right? They're starving, they haven't eaten all day. They see this. They're gonna grab one. Do they have freedom to choose? 6 donuts, right? They grab one. That was only 5 left. The next student walks in the door. Ooh, donuts, hungry. Do they have freedom to choose?
1 less.
All right. There's 5 left, but they have still some freedom. The next one enters, the next one enters, the next one enters. Now everyone's taking the donut. The 6th person walks in the door. There they come. Donut, they see the sign. They come up in the box. Inside the box, there's that one plain donut. It's already getting kind of hard and stuff, right? It's getting kind of stale, but there it is. And they're starving, so they're going to grab it. But did they have any freedom to choose?
No.
No, they were stuck with the what? That plain. They were the one that didn't have any freedom. So there were what? 6 donuts, but there were what? 5 degrees of freedom. Does that make sense? So that's what we mean by degrees of freedom here when I'm saying there's 4 degrees of freedom. All right, so I think we got this thing all worked out except for one thing. Look at the numerator. Something's not working properly. If we're trying to get an idea of how things are spread out, mathematically, something funny's going on. We're going to have to fix it. Y'all notice it?
It will be like 0.
See, I heard people saying you get some negative numbers popping up. 1 minus 3 is what?
-2.
Negative 2. You get a negative 2, and over here you get a positive 2.
0.
And a 1 over here, but this is a...
1.
So this isn't going to work out mathematically, because in the end we're just going to get like a 0. That's not really telling us about the spread of data, right? So in this math formula, this is standard. It's called the sample standard deviation. The standard deviation equation requires that you square all the deviations. So would you put squares on each deviation? See, that makes them all positive, right?
Why can't you take absolute value?
I know, you could actually. You know? It could be the art formula. So I'm just going to take the absolute value of all these. And we're going to have to offset that eventually.
I know.
But this is for the find the what? Sample, the word standard. Maybe ours would be the art deviation formula. Hey, let's see what we get here. I'll let you sum up all those numbers in the numerator, and we're going to divide it 4. I'm trying it mentally, everyone. I'm getting 10. So could you verify that? It's like a 4 plus 1 plus 0 plus 1 plus 4. 4 plus 1 plus 0 plus 1 plus 4. 10. And 10 over 4 is?
5/2.
5 over 2, I think I'll write it as a decimal.
2.5.
2.5. forget, there's 3 steps. See, the third step, we're just gonna have to offset all those squares we're doing. But is everyone okay with this? There is a name for this number. And I wanna make sure everyone knows what this name is. In step 2, it's not the sample standard deviation. There's a name for this. All that right there in step 2, this is called the sample variance. It's called the sample variance. And eventually I'll show you the symbol. I can't show it to you yet. I'll show it to you. That's the sample variance. Varies, you think about varies, things what? How far away, right? The sample variance. And if you wanted to define that, look, it's the summation of the squared deviations, right? Divided by the degrees of freedom. If you want to talk like a statistician, true? It's the summation of the squared deviations, that's a deviation, that's a deviation, that's a deviation, divided by the degrees of freedom. Yeah. So what do you get? You get what's called the sample variance. All right, step 3, final step. How do you get the sample standard a deviation? One quick step.
For the numerator, will you always square it?
Always. And it's part of the standard formula. You got it. Great question. And now for this last step, I have to offset all those squares I was doing. So you know what we do? We take the square root of the variance. You take the square root of the last number. Does everyone know where the square root button is on your calculator? So I got to take the square root of what?
2.5.
2.5. Now, this can go out to about 8 places on your decimal, after the decimal place. It can go out about 8, even more places on those calculators. I say let's just take this out to 2 decimal places, whatever we get. We've got 2 decimal places. Put a little squiggle for equal sign. What are you getting? 1.58. 1.58? So I'm curious, what did it do? 1.5 what? 1.5811, blah, 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 blah. We're going to say, all right, the sample standard deviation is 1.58. Now I'm going to show you these symbols. This is for a sample, right? Thankfully, they came up with a nice letter for sample standard deviation. Sample starts with what letter? S.
Yes.
Standard starts with what letter?
S.
S? It's an S. So now, I can show you the symbol for sample variance, sample variance. It would just be that squared. So when the symbol for sample variance is just S squared. It's squaring that. You square that, you come to here. Right? So S is equal to 1.58. Hey, TID3, TID4 calculators, when we find this on our calculator, it writes it like this. It puts a subscript of X off the S. It's like the standard deviation of all the X values. So I just want to let you know that's how it looks on your calculator. You'll see an S with an X as a subscript.
So X is always represented as standard.
You bet. And it's a lower, if you're curious, like in the textbook, and you look on the internet, it's lowercase s.
So it's always going to be
Yep.
sample standard.
And that's always a sample standard deviation. So you go, all right, what's population standard deviation, right? We'll get that some in a second. Is everyone okay with this?
Mm-hmm.
All right. Hey, more important than the tedious calculations, seriously, is understanding what this basically is doing for us. What does this measurement mean? So you go, what is 1.6? Well, we said it's the average deviation from the mean, right? So let's go back and look. The mean was 3. How far away is that from a 3?
But 2,
How far away is that from a 3?
1.
How far away is that from a 3? It's right on it, 0. How far away is that from a 3? How far away is that from a 3? 2, 2, 3, 1, 2. I mean 2, 1, 0, 1, 2. All right, on average, we're saying these data, each observation is roughly about what? 1.6 away from the mean. Gives you a sense of what's going on in terms of spread of data. And the more spread out, this gets really, really what? Big. Data's all tight. Think of a class and how the students did on a test. You know, if the standard deviation is really small, they all scored close to each other. But if they're all over the place, it'd be very big. All right. Hey,
So in a case of outlier, the standard deviation might be really high.
you bet. That can really take, it totally affects it. Just one of them, right?
Yeah.
Just one of them can really affect that. I love it. All right, so that's the sample standard deviation. I say we create what the math formula would look like. Because there's a formula and it's attached to your test. It'll be there for your test, the next test you take, even on the final, but you want to see what it looks like? I say we create it, all right? What's the formula for sample standard deviation? What would S be? And if you want to put a little subscript X, you can, because the calculator does it. Let's see. First thing, it looks like I have to add things up, right? And when are we adding things? So what's the symbol for adding things?
Sigma.
Yeah, remember that things? That's the capital sigma, Greek letter sigma. I had to sum each one of these x values, but there were different x's, so I'm going to put x sub I. And what did I subtract from each x?
Mean.
And what's the symbol for the sample mean?
X bar.
X bar. So I'm going to put x sub I minus x with a bar over it. I'll close the parenthesis, and don't I have to square these?
Yeah.
And then I'll put a big fraction, and then underneath I put not n, but n minus 1.
1.
And there's one more symbol I have to add to this. What do we do in step 3?
Square root.
So this thing looks like a monster, doesn't it? Look at that. Make sure I get that radical in the whole. So when you got the formula sheet the first day of class, some of you might have looked at that and went, good golly, what is going on in this math class? But once you do it, you go through it, you go, oh, that makes sense to me now. Summation of the square deviations divided by the degrees of freedom, then you take the square root of that, right? And if you just want the variance, you lift off that radical hat. It's just that squared. Cool? Awesome. Awesome. Now, hey, I want to show you these symbols for population. Okay? Can I erase all this? All right. I'll take this out of the way, get this out of the way. I just want to show you the symbols so we can stay organized before we lose sight of all these funny symbols popping up. I say we start with mean, and then we'll do standard deviation.